Okay, so we've talked about basic synthetic division now. And the reason that we do synthetic division is it's part of the process for trying to figure out what the zeros of our polynomial are going to be. So what if you go through all that synthetic division and you find that it doesn't come out even, that the remainder is not 0? Well, that's still beneficial to us. It just so happens that when you synthetically divide by that number k, the remainder r is actually the value at that position k. So in other words, it's like plugging x in and figuring out what y is. Doesn't seem like much, but it's actually a lot easier to do synthetic division and get that remainder than it is to actually plug x in to the original function and go through those motions. And like I said, if the remainder is 0, then k is a factor of the polynomial, a 0 of it. So let's look back to the first example that we did for synthetic division. Look like this. Alright, we had a remainder of 1 when you synthetically divide by -3. Okay, what the remainder theorem is saying is that the value of the function when x equals -3 is 1. Alright, so in other words, instead of having to plug -3 into the whole function and crank it out, you can use synthetic division, which is much quicker and much easier. Because here's what it looks like if you were to actually substitute -3 into x to the 4th minus 10x squared minus 2x plus 4. You got -3 to the 4th power, you got -3 squared. I mean, can you do that? Yeah. Is it easy? Somewhat easy, but it's tedious. It's work. It's a lot easier for us to go through that synthetic division and find out what the remainder is that way. So here's the proof. You plug that -3 in, you do get 1. Yeah. Typically using the remainder theorem is much easier than plugging the values in directly, especially if you have fractions. Alright, so let's try another example. Find out what y is when x equals -1 and use synthetic division to do it. Alright, this gives us a little bit of practice on doing our synthetic division. Bring the coefficients in the box, put -1 on the outside, and should look like this. There you go. The remainder theorem tells us that f of -1 is 1. So there'll be some problems where they ask you to find the value at x equals whatever. This is the way you do it. Use the remainder theorem for it. Okay, so another thing. Yep, I think we've already established that. Another thing, factored form. When asked to express an answer in factored form, it doesn't change your work at all. You're still going to go through the same process that you have in the past. It's just another alternative way to express the answer. And it looks like this. F of x equals x minus k q of x plus r. So let me just interject here for a second with some terms that I've used I haven't really explained in the past. So if you have division going on, and I'm just going to make up some stuff here. Let's say you have x plus 2 there. You got 3x cubed minus 2x squared plus x plus 1. And I'm not going to go through the division, but let's say that you get something up there plus a remainder. All these things have names, so you may want to jot this down. What you're dividing by is called the divisor. What you're actually dividing is called the dividend. Okay, what you get here is referred to as the quotient. So you could say the answer without the, well, with the remainder, but the answer is the quotient. And then of course you have the remainder at the end. I think everybody knows what the remainder is. So we got the divisor, the dividend, the quotient, the remainder. Okay, so this is the whole function. Factored form is writing the divisor in parentheses times the quotient in parentheses and then adding the remainder. So they may ask you to put it in that form. Alright, so let's go over that again. X minus k is what you're dividing by, which is called the dividend. No, that's not true. I got to scratch that. It's the divisor. Alright, continuing on. So scratch that. Make sure you make that adjustment. What you get is the quotient, and r, of course, is the remainder. Okay, so let's see what it looks like when we do something and express it in factored form. Here we have factored form. Here we have what we want to divide by. Well, the dividend and the divisor. And good chance for us to practice some synthetic division, so go ahead and try that right now if you dare. Okay, here's what our synthetic division is going to look like. Hopefully you guys get that okay. Alright, and now we want to express it in factored form. So you're going to take what you divided by. Again, divisor. Times the quotient. The quotient is going to be right there. And then add the remainder. And that would be your final answer. Alright, that's referred to as factored form. Let's try one more. Okay, pause the video. Oh, you're lucky. I didn't give you a fraction to work with. Pause the video, do your synthetic division, and express your answer in factored form. Alright, should look like this. Well, how about that? We have a remainder of 0. So that means the r part of the factored form isn't necessary. So we're going to take what we divided by the divisor, x minus 1, times the quotient, which is 3x squared minus 2x plus 4. And there is no remainder to add. So that is the final answer. That's how you express things in factored form. Till the next time, friends.